All right. Let's go ahead and look at 11.2 compound interest. So, in the previous video, we discussed simple interest, and now we're going to move into our second type of compound. So, for our simple interest, typically we use those for loans and investments that are 1 year or less in length. Whenever we start talking about multiple year loans and investments, we often start discussing compound interest. So, what's the big difference? Well, simple interest, if you recall, relies on what is the original principal for the entirety of the timeline. Whereas compound interest is calculated not only on the original principal, but also any interest that you earn along the way. So that might sound a little bit confusing. So let's look at a general scenario. Let's say I have a savings account and I deposit $1,000. And if this saving account earns a 5% interest, and let's say we calculate it once a year, then what happens during the first year? Well, during the first year, we can still use our simple interest formula. I is equal to PRT. Well, if I plug in my principal of 1,000, my 5% interest rate, and then 1 year for my timeline, that gives me an interest amount of $50. So therefore, after 1 year, my account should be worth $1,050. What happens in the second year? Well, in compound interest, since I calculate each year in this scenario, for year two, I look at my new original principal. My new principal, instead of 1,000, is now 1,050. I still have my 5% interest rate, and I am 1 year in length for my new year. So for the second year, assuming I don't touch my investment account, the new interest is now $52.50. Therefore, within after 2 years, my bank account went from $1,000 to $1,102.50. So notice here for each year, I changed the principal. And this is the key part for compound interest. If I was doing simple interest for the entirety of the 2 years, then my amount is going to be a little bit different. It's still going to be based off that original 1,000. Whereas for compound interest, I set a compound period, in this case 1 year, and I recalculate each year. So, as I said, in that scenario I just talked about, interest was compounded annually once a year, but we could be compounding our interest semi annually, so twice a year, quarterly, 4 times a year, monthly, 12 times a year, or daily. And remember, whenever we're talking about days in a year and our interest, we're going to lean towards the ordinary method where we say 1 year is 360 days. So the frequency in which the interest is compounded, that is how many times per year I make my calculations, we call this the compounding period. So we're going to use and call these values of n based on the number of compounding periods. So annually would be once a year, semi-annually would be twice, quarterly would be 4, monthly 12, and daily 360, as I mentioned earlier. So how do I calculate my compound interest? Or in particular, how do I get my compound amount? So here we're going to use this formula for the compound amount, which is the sum of my principal, so my original investment, plus any interest that I earn on this account or additional interest that's owed on the account if I'm talking about a loan. So here A is a compound amount. Remember, we used similar notation before. A is equal to the principal P times, in parentheses, 1 plus the interest rate R divided by N, the compounding period, all to the power of NT. So we have this formula. It looks a little complicated, but the big thing is making sure that we're keeping track and putting everything into the right spot and making sure we're doing everything in the right order. So, for example, Let's say if I look at this first one, suppose I went and deposited $500 into an account that earns 6% interest compounded semi-annually. I want to ask, how much is the account worth after 3 years? Big word here that I'm noticing is the word compounded. This is telling me I'm working with compound interest, compound amount. So what was our formula? Well, remember, I'm going to go back a slide. We had this formula, A is equal to P 1 plus R over N to the NT power. So let me go ahead and copy that down. We had our compound amount, A, was the principal 1 plus R over N to the NT power. So I want to figure out how much is the account worth. So in other words, what is A? And if I want A, then I need to fill in the rest of these. P, R, N, and T. So we're familiar with most of these. P is my principal. What is my original deposit? Well, in this case, my original deposit is the $500. R. R stands for my interest rate, or in this case, 6%. That is 0.06. Remember, we don't want to write 6. We want to write it as a complete decimal. I'm going to skip to T. How long am I waiting on this account? Well, if I read the question, we know that we're waiting 3 years. The last thing I need is N. Well, remember, N is how many times per year am I compounding? Well, if I read my sentence instructions, we say that we're compounded semi-annually. So if I'm doing semi-annually, how many times is that per year? Well, that's twice per year. All right, so now that I have labeled all of my variables, let's go ahead and plug everything in. E is 500. We have 1 plus R 0.06 over N to the power of N times T. I went ahead and plugged everything in as needed. So whenever I'm calculating this, I want to be careful because it's very easy to make a mistake. So I'm going to do this one step at a time. Well, at least explaining it a little bit. So I have 0.06 divided by 2. That gives me 0.03. To the power of 2 times 3, we have to the power of 6. And then now I can go ahead and write this as 500 times 1.03 to the 6th power. Now from here, I can be a little bit more comfortable with putting this into my calculator. So if I try to calculate this, we should be getting, if I did my calculations correctly, approximately $597. And let's see if I round to the nearest cent, and 3 cents. So we calculated the compound amount. In other words, if I have this scenario, then after 3 years, I'm expecting to see not $500 in my account, but instead $597.03 in my account. So this is our example. Let's go ahead and move on to another one just for practice. So if I look at my next example, again, let's calculate the compound amount. So I'm going to go ahead and write my formula. A is equal to P 1 plus R over N to the NT power. I'm going to go ahead and write these as well. So I just got all this from just reading calculate the compound amount. When $10,000 is deposited into a savings account earning 8% interest compounded quarterly for 4 years. So let's go down the list. P, what is my principal? Well, my principal in this case is the $10,000. What's my interest rate? Well, this account is 8% or 0.08. Next, let's look at N. How many times per year am I being compounded? Well, here it says compounded quarterly. And we know quarterly means 4 times a year. So N is 4. Lastly, is T. What's my time? Well, here I'm waiting for 4 years. So I have all of my values, and now I just have to plug in everything into the right spot. Compound amount is 10,000 times 1 plus r over n to the nt power. All right, so once again, I'm just going to clean this up a little quickly. I have 10,000. 1 plus 0.08 over 4. We should be getting, what, 1.02 to the 16th power. If I calculate all this, I should be getting about $13,727. And let's see if I round it. Actually, I don't need to round. In this case, 86 cents. Make sure that you're getting the appropriate answer. So in this case, I deposited $10,000, waited for 4 years, and now my account is worth a total of $13,727 and some change. One thing I want to note here is that we don't really want to do any rounding until the very end. If you round a little bit earlier in the process, your answers might be off by a couple of cents or maybe even up to like $1 or 2. So we really want to avoid rounding until the very end of my question. All right, so we've worked with some compound amount and how to calculate that. Let's move forward. I'm going to go ahead and skip example 3 because it's basically the same question. Now I want to take a little bit of a reverse on this. Here, so far, I've been mentioning we deposited or borrowed this amount. How much is it worth after so many years? But what if I want to ask the opposite question? In other words, what if I want to ask, for example, if I want this much money after 20 years, how much money do I need to start off with? In other words, what do I need to be my principal to get this particular future value? Well, this is what we're going to call our present value, or in other words, our original principal. We're still using P for this. And this is actually the exact same formula, just rearranged. We have P, the principal, is the compound amount or future value A, divided by this 1 plus r over n to the nt power. I want to emphasize this is the same formula we did before. It's just that I solved for P instead of solving for A. This formula will allow me to calculate how much do I need right now in order to achieve some type of future value. So let's do 2 examples with this. For example, how much money do I need to invest if I have an account that earns 8% interest compounded annually if I want to have $30,000 in 5 years? So here I'm asking not how much is it going to be worth, but how much do I need right now? So I'm going to use my present value formula, which is P is equal to A over 1 plus R over N to the NT power. And I want to figure out what my principal should be. All right, so just like before, I'm going to write all the other variables down so we have them. First off, A, my future amount. How much do I want this account to be worth? Well, I want this account to be worth $30,000. What's my interest rate R? Well, for my interest rate, we have 8% interest, or in this case, 0.08. Next is N. How many times per year am I compounded? Well, in this case, we are compounded annually. Annually is how many times per year? That's once per year. And how long am I waiting? Well, I'm waiting for 5 years. Now we've done a lot of the hard work. Now we've got to plug in A, R, N, and T. So this gives me A is 30,000. Let's hope I write enough zeros. Over 1 plus the rate over N, which is 1, to the NT power. So we definitely want to be careful as I'm going through this. So for now, I'm going to leave the top alone, 30,000. And I'm going to try to clean this up one by one. 0.08 divided by 1 doesn't change anything. And then I can add 1 to give me 1.08 to the power of 5. Now, if I calculate this, we should be getting, let's see, 30,000 divided by 1.08 to the 5th power. We should be getting, I believe, 20,417 and 50 cents. So, what does this mean? This means that if I want to have $30,000 after 5 years, right now I need to invest $20,000, $20,417.50. So again, in this example 4, we're not asking how much is it going to be worth. We're asking how much do I need right now to get to my goal in 5 years. And another thing I'll mention is, of course, this is a very ideal scenario. This is assuming that my investment rate stays the same and that I'm not adding more money. I'm not taking any money out. In other words, it looks like I just put in the money. I didn't touch it for 5 years, and now it is worth $30,000. So that was our example 4. Now let's look at our last example for this video, example 5. So this may be something that's either relevant to you or will be relevant to you in the future, especially if you have children. Let's say that we have a couple here and they want to save for their kids' college fund. We all know college can be really expensive. What principal must be deposited by the parents when their child is born if they want their kid to have a college fund of $61,000 by the time they turn 18? And again, let's go ahead and assume that we have an 8% interest rate on the account and we're compounded quarterly. So this couple is having a child. They want to deposit some money into the kid's bank account and they just want to let it sit there for 18 years. They're wondering how much do they need to put into that account so that their kid has $61,000 by the time they turn 18. The other things I'm going to note here is, again, this is under the assumption that we just have the money at the very beginning and we put it into the account and then we never touch it until they turn 18. We're not going to talk about what happens if I add a little bit more each month or anything like that, because then things get a little bit complicated. So I want to find the present value or the principal. So I'm going to go ahead and write the same formula I had before. P is equal to A divided by 1 plus R over N to the NT power. Again, I want to figure out what P is. And I'm going to go ahead and write the rest of these variables. So starting off with A, how much do I want this account to be worth at the end of this time period? Well, ideally, we're looking for them to have $61,000 by the end of all of this. What's R, my interest rate? 8%, or in other words, 0.08. How many times am I compounded per year? Well, I'm compounded quarterly. quarterly translates to 4 times a year. And for T, how long am I waiting for this account? Well, we're waiting 18 years. So now I'm going to go ahead and plug in all these values. A is 61,000. We have 1 plus 0.08 over n to nt power. So again, I just plugged in A, R, N, and T. Now my job is making sure that I clean all this up properly and that I'm not making any mistakes. So for now, I'm going to leave the top alone because 61,000 is by itself. And then from there, go ahead and write that. We have 1 plus 0.08 over 4. That's going to give me 1.02. And then 4 times 18. Well, let's see, 4 times 18. We should be getting, I believe, 72. And now I'm at a point where I'm a little bit more comfortable writing this all and calculating this all together. If I do 61,000 divided by 1.02 to the 72nd power, this should translate to $14,659.44. So again, what does this mean? This means for this for this child to have a college fund of $61,000 by the time they turn 18, their parents need to invest or deposit $14,659 and some change into an account. That sounds like a lot. But again, remember, this is under the assumption that they just put the money in and then they never touch it. The interest rate stays stable and everything like that. Whenever you're actually trying to save for a college fund, most people, they probably either um, deposit a little bit each month and stuff like that. So if you're trying to do some college planning for children in the future, your process might look a little bit different than what you're seeing. But this does give us an ideal scenario. All right, besides that, that is all I have for this lecture video. I'll see you actually in the next month.